Okay, now we're going to discuss how to find x-intercepts of a rational function. And before we go into finding x-intercepts, I want to go over domain again. Okay, when we were finding the domain of a rational function, we're going to do this one first. What we're looking for are x values that are not valid for this function. Which x values will not be valid? The ones that will make the denominator equal 0. So when we look for domain, we always work with the denominator to see what x value will make this denominator 0. And what we do is we take our denominator. I'm going to work up here because this space down here I'm going to use for the x-intercepts. We take x minus 1 and we make it equal 0, and that way we can find what x will make this happen. X equal to 1. So when I write my domain, I say, well, any number works as an x value for this function, but not x equal to 1. So I exclude that value because if I plug in x equal to 1 in this function, I will get a number in the numerator, that's -2, and in the denominator I'll get 0. So I would get 2 over 0, and that is undefined. Anytime you have anything divided by 0, it's undefined. So it can't be part of the domain of the valid values for x. So the way Mr. Crespo put it, and I love the way he put it in his class, the way he sees this, is that the domain the domain is like a party list, okay? And in this party list are all the people that you want to have fun with. All your friends are in this party list. And these are the party poopers. These people here, the excluded x values, are the people you don't want in your party because they're going to ruin things. So x equal to 1 would be a party pooper. He's not in the party list. He's not included in the domain, okay? So you have to watch out for him. Make sure he doesn't come in. And you'll see what I mean by that when we look for the x-intercepts, okay? So now let's go into how to find the x-intercepts. To find the x-intercepts, all you have to do is you make the numerator equal 0. It's like solving the function. Remember, x-intercepts means y is equal to 0, and f of x is the same thing as y. So that's why I'm writing 0 in place of f of x. And then I write my numerator. The numerator is just the top part of this ratio. And now I solve this, and I have many ways of solving this. I can factor, I can use quadratic formula, I can try and complete the square, etc. But we're lucky because this factors. So this would be x, I'd have a -2, a +1. And with the zero product property that says if this times this is equal to 0, then this has to be 0 or this has to be 0. So I'm going to solve. X minus 2 equals 0, x equals 2. And x plus 1 equals 0, x equals -1. Now these are my possible x-intercepts. Why do I say possible? Because maybe they're not in the party list. So let's check. We already know x equal to 1 is not on the party list. So that's the only x value that's a party pooper. All the other x values are good to go. They can come in. VIP passes. So x equal to 2, that's in the party list. X equal to -1, also in the party list. X equal to 1 is nowhere to be found in my x-intercepts. That means that these two values that I found are my x-intercepts. And here they are, 2, 0 and -1, 0. Another way to look at this is once I find my x x-intercepts, my possible x-intercepts, you can go ahead and check each one in the numerator by plugging that value in and making sure that you don't get 0. So I would go ahead and say, well, x is equal to 2. I'm going to plug in a 2. 2 minus 1, 1. I'm good. I didn't get a 0. This is an x-intercept. Now I take the next one. I plug it into the denominator again and check. X equal to -1. If I plug in -1 minus 1, I get -2. Good to go because I didn't get a 0. So you have two ways of doing it. If you have the domain restriction already, then it's easy to just, once you get your x-intercepts, make sure it's not in the party pooper list, okay? If you get an x equal to 1, then you know that cannot be an x-intercept. It's not on the party list, okay? Let's do the second example. Find x-intercepts. You can go ahead and find the domain so you already know what x values are not going to be allowed to be x-intercepts, okay? So let me do it here. To find the domain x minus 4 equals 0, I want to find out what will make my denominator 0, and you can see it clearly. If x is 4, you'll get a 0. But I like to work it out just so that you get used to establishing the rule and solving, just in case it's not this simple. So x is equal to 4. So if I write my domain for this function, everyone's invited except poor number 4. 4 is not part of the party list, okay? So let's watch out for this number when we find our x-intercepts and make sure he doesn't sneak in, okay? So this is what we do. First step, we substitute 0 for f of x, which is our y. Remember, for x-intercepts, y is equal to 0. And we work with our numerator, x squared minus 16. How do I solve this? I can take square roots on both sides. I can factor. I like factoring, so this I can factor. This is a perfect square. So xx plus 4 minus 4. I use my zero product property rule, which says that if this times that is 0, then this must be 0, and or this is 0. So x plus 4 equals 0, x equals -4, x minus 4 equals 0, x equals 4. Now, these are possible x-intercepts. Is someone trying to sneak into this party? I think so. X equal to 4. We had already said I cannot have x equal to 4 in this party. And he's trying to sneak in. So x equal to 4 will make my function undefined. So this cannot be an x-intercept. Okay, so if I plug in 4 into my denominator, I'll get a 0 here. So he can't be an x-intercept. The only x-intercept I'll have is -4, 0. Okay, I hope this makes it clear for you, and I want to thank Mr. Crespo for using this analogy about the party list and all of that, because it really makes it understandable. Okay, don't try to memorize these steps. Try to understand what's happening and use your logical thinking to see what's going on, okay? Have fun with this. I'll do 2 more examples in another video, and then we'll go into explaining wholes.